Hello guys, this is our final year project over performance test on diesel engine with biodiesel, mustard oil and sunflower oil with varying injection pressure, performed by Shailendra Kumar Yadav and Sri Bhagwan Singh Yadav under the guidance of J.M. Babu, Assistant Professor Mechanical Department. The main objective of our project is to find an alternative fuel to the common fossil fuels such as petroleum and diesel. The fossil fuels are being extracted at a very high rate, so in the next 35 years there will be a huge demand to an alternative fuel because the fossil fuels will get exhausted. The use of fossil fuels causes various environmental effects such as global warming and greenhouse effect. The use of biodiesel will reduce these environmental effects to a higher extent. Abstract. Biodiesel is an eco-friendly, clean alternative diesel fuel that is derived from oils and fats of plants like sunflower, mustard and jatropha. It can directly be used or blended with petroleum-derived diesel. Biodiesel is prepared by a process called transesterification. The process of converting vegetable oil into biodiesel fuel is called transesterification. First, the vegetable oil is put into a tank for processing. Methoxide is the mixing tank where the catalyst and methanol are mixed before used. Introduction. Manufacturing biodiesel from used vegetable oil is relatively easy and possesses much environmental benefits. The use of biodiesel vegetable oil as frying oil produces significant amount of used oils which may present a disposal problem. Mustard is one of the most used edible oil with large production potential of about 60 million tons per annum in India. The experimental investigations reveal that the better performance among the biodiesel blends is obtained at the injection pressure of 225 bar with B20 of sunflower seeds and mustard oil blends. Need to study. First of all, we have to study about the properties of diesel and biodiesel. Then the 4-stroke diesel engine specifications have been specified to conduct a performance test on 4-stroke single-cylinder diesel engine by using diesel as a fuel. After that, thermal efficiency, mechanical efficiency and brake thermal efficiency are calculated from the above readings. To study the different properties of mustard oil and sunflower oil, transesterification process is done on the alternate fuels by reacting with alcohol to get the required biodiesel. After getting the biodiesel from above process, it is blended with diesel to go from the performance test on the diesel engine. At last, we will get to know all the properties and performance of the 4-stroke diesel engine by using alternate fuels. Experimental setups. The engine selected for our experiment is a single cylinder 4-stroke direct injection water cooled diesel engine connected dynamometer for loading of engine. Experiments are conducted with pure diesel and blends of mustard oil and sunflower oil. Provisions is also made for interfacing airflow, fuel flow, temperature and load measurement. The results obtained after experiments is compared pure biodiesel blend results. Time plan. First, selection of biodiesel, experimental setup, then blend preparation, after that esterification, then preheating, followed by performance test on engine, and the last results and conclusion. Engine specification. Make of the engine Kirloskar TV1 engine, BHP 10 bhp at 1500 rpm, bore and stroke length 87.5 into 110 mm, stroke volume 661.45 cc, compression ratio 17:5:1, connecting rod length 234 mm, dynamometer eddy current type. Analysis and calculation. The engine is a 4-stroke CI engine connected with electrical dynamometer with water rheostat. The load is applied electrically. The burette is connected to the engine through the 3-way cock to measure fuel consumption. Spring balance readings are indicated by swinging balance dynamometer. By noting the values of load in the spring balance and time taken for 10 cc of fuel consumption, graph of performance characteristics are obtained. Formulas used. Brake power 2 pi nt by 60 into 1000 kilowatt. Fuel consumption is equal to 10 cc by torque into specific gravity into 3600 by 1000 kilogram per hour. Specific fuel consumption is equal to fuel consumption by brake power kg per kilowatt hour. Indicated power is equal to brake power plus frictional power. Mechanical efficiency is equal to brake power by indicated power. Thermal efficiency indicated power into 3600 into 100 by FCH into calorific value. Brake thermal efficiency equal to brake power into 3600 into 100 by fuel consumption into calorific value. Work done on engine. The engine is started under no load condition by hand cranking using decompression lever. Open the cool water line to the engine and allow the engine to run for some time. The time taken for 10 cc of fuel consumption is noted using stopwatch under no load condition. Now the engine is loaded to 25%, 50%, 75% and 100% of the rated load, and all the observations are recorded under steady state condition. This is the experimental setup of Kirloskar TB1 5 bhp engine. Fuel injectors. This is the fuel injectors where the pressure is varied from 175 bar to 225 bar. This is the experimental setup for the fuel injectors. The properties of the diesel. Density. Density of the diesel is 828 kg per meter cube. Specific gravity is 0.828 Newton. Kinematic viscosity is 3.78. Calorific value is 42960 and flash point in Celsius is 56 degrees Celsius. This is the tabulation column for engine testing with pure diesel. This is the graph between brake power and fuel consumption when the engine is tested using pure diesel. Efficiency. The thermal efficiency obtained using pure diesel is 38.82% and the brake thermal efficiency is 17.18%. Transesterification process. Transesterification process is used to reduce the viscosity of vegetable oil and produce the biodiesel. Transesterification process of vegetable oil, a tricycled reacts with an alcohol in the presence of a strong acid, producing a mixture of fatty acid, alkyl esters and glycerol. Alternate fuels. Mustard oil is a vegetable oil pressed from the seeds of mustard. Scientific name Brassica nigra. Sunflower oil is a compound consist of several fatty acids. Scientific name Helianthus annuus. Flash point and fire point of biofuels. Kinematic viscosity at 400 Celsius is 5.11. Density is equal to 881.2 kg per meter cube. Flash point is 160 degrees Celsius. Fire point is 186 degrees Celsius. Pour point is 4 degrees Celsius and calorific value is 42293. Procedure to find flash and fire point. Calorific value, which indicate the energy content of the fuel using ECO bomb calorimeter. The flash point was established using a crude method where a fuel sample was heated on a stove with magnetic sphere within it. Temperature was continuously monitored using a thermometer. Flame was ignited at the mouth of the beaker with a sample. The minimum temperature at which the fuel ignited was recorded. The procedure was repeated to obtain mean values. Buffer were used for calibration. An estimate of chain length was obtained by analyzing the integrated packs of the portion or carbon. Mass gas chromatography MSG was established. Contents present in the biodiesel was produced. This is the observation and results of the biodiesel at 175 bar injection pressure when the engine is run at biodiesel mode. This is the chart for efficiency, power and ratio observations. This is the chart for observation of the results at 200 bar injection pressure at the biodiesel mode. This is the calculations table, that is efficiency, power and ratio observation. This is the observation and results at 225 bar injection pressure at biodiesel mode. This is the chart for efficiency, power and ratio observation. This is the comparison of brake thermal efficiency at varying injection pressure. When the injection pressure is 175, the average brake thermal efficiency is 21.4719, and when the injection pressure is 200 bar, the thermal efficiency, that is average thermal efficiency, is 22.7767. When the injection pressure is 225 bar, the average thermal efficiency is 23.9672. This is the comparison graph of brake thermal efficiency versus varying injection pressure. Conclusion. Using biodiesel B20, we find that the efficiency of the engine increases with the increase in injection pressure. The emission of exhaust gases is controlled. With the increase in injection pressure, brake thermal efficiency and volumetric efficiency is increased. The maximum brake thermal efficiency is obtained at 225 bar injection pressure using biodiesel B20. Thank you.